Hey everyone, Nitesh this side. Hope you're doing well. So let's start with the question. So the question is search in a 2D matrix. So you have to write an efficient algorithm that search the value in a target in a m cross an integer matrix. And the matrix has some properties. So integer in each row are sorted from left to right, and the first integer of each row is greater than the last integer of previous row. Okay. So in the matrix, the all element are in the sorted. So from left to right, they are in the sorted, and if you can see for the first row in the last element, the next row will always have the bigger element than that. Okay, so this 20, as you can see, this 23 have the bigger value than that. Okay, so let's see how we can approach this question. Okay, so let's take this example. So we have 1 3 5 7, then we have 10 11 16 20, and this is 23 30 34 60. Okay, so this is having a row of 3 and columns are 4. Okay, let's give the indexes 0 1 2 0 1 2 3. Okay, so what we have to search, we have to search 3 in this matrix. Okay, so our target is 3. So as you can see, this 3 is present here. Okay, so we need to return true. If the element is not present, then you have to return false. Okay, so if I go with the naive approach, what I can do, I can basically iterate whole my matrix like by this, and I will iterate this, then this. So what I will do, I will take a loop from 0 to n, then for 0 to m, and I will check if the value is equal to target. I will just return true. Otherwise, I will return false. Okay. So as you can see, this will taking a time complexity of order of n into m, and m is only having 100, so it's basically 100 into 100, so it's a 10 to the power 4. So if you go with this approach, this will be like your code will be submitted. Okay, so can we optimize it? Oh, so if you can see, this matrix is already in the sorted order. Okay, so let's see how we can optimize it. What we will do, like every element is sorted from left to right, and the next element is always bigger. Okay, so what we can do, we can start from here. Okay, so we will stand at here. So our I is at this position, and j, like j will pointing to 3 and I is pointing to 0th index. So why I'm taking this position, because it will, like, the element before that is always smaller and element after that is always greater. Okay, so that's why I choose this index. So what we will do, we will basically check whether is this element is equal to target. If it is equal to, so we just return true. Otherwise we'll go in any one direction, either we'll go in this direction or either we'll go in this direction. Okay, so as you can see, 7 is lesser than 3, so that means element will be present in the left side, not in the right side, because right side have right or bottom, like bottom have the greater element. So we'll come at this position, so we'll see it here. Okay, now let's say you again check your value with target. So target is not equal to 5, so you again go to only one direction, which is lesser. So you will go to here and you can see your target is equal to. Okay, let's say you have to search 30. Okay, so what you will do, you will go from here. So you are at here at this position. Now you will check whether 7, like your target is greater than 7 or not. You can see this, it is greater than target, so you will go in this direction. Okay, now again you will compare whether this 30 is greater than 20. Either I have to go this direction or this direction. So this is greater, so I will go in one direction. So now again I check whether this is equal to target. No, this is not equal to target. And is it greater than target, sorry, value? So it's not, so I will go in this direction, it's lesser. Similarly, I will go lesser direction and I can found the element. Okay, so as you can see, we are going either on one direction. So that will basically, you can say, from order of n into m, we come to order of n. Okay, so you can easily like take the pointer from here and here, and you can compare your value. So by this way, your code will be also submitted by order of n approach. Okay, but there is one more approach which is much better than both the approach. So let's see. Okay, so let's see how we can optimize it more. As you can see, this is already in the sorted manner. in a sorted manner from left to right, and also the next row have the bigger element than this. Okay, so it's just like, if you can see, this is also a sorted list. If I just write down here, so 1 3 5 7 10 11 16 20 23 30 34 60. Okay, so this is also a sorted list, you can say. So if I give the indexes, so this is 0 1 2 3 4 5 6 7 8 9 10 11. Okay, so this is a sorted list and you have given a target, so you can implement a binary search over it. So because the element list is already in sorted order, and for searching you can use binary search here. Okay, so let's apply the binary search at here also. So what we will do, we will take our low at this position. So low is at here, and let's say the low. So, and let's take our high at here. Okay, so what we will do in binary search, first step is to calculate mid. Okay, so we have calculated the mid. So your low is 0 and your high is basically like, you can say, let's say this is having a 3 and this is having a 4. So you will give this value is m cross n minus 1. Okay, so m cross n minus 1. So this is 12 minus 1. 3 into 4 is 12 and minus 1 is 11. So if I mark the indexes here, 0 1 2 3 4 5 6 7 and 8 9 10 11. Okay, so we'll calculate the mid. So 0 plus 11 divided by 2, which is 5. Okay, so what we can see, mid is at here and your low is at here and your high is this position. But how can you identify this 11 value at this array? Okay, so like if it is in the in a list, then you can say like this is the middle element. But in terms of 2D matrix, how can you give this as a middle? How can you make this as a middle? So because the row is 1 and column is 1, so how can you get this value row as 1 and column as 1? So what we can do is, like, we need to calculate the row and we need to calculate the column with the help of mid. Okay, so what we know, like mid will be at 5. Okay, and we know at every, you can say, at every row you have 4 columns. Okay, so this is having 4, this is having 4, this is having 4. So if I want to identify which part of this row is this, so what I will do, for row I will do mid divide by, you can say, m. And for column, if like I know the row but I want to know the column, so what I can do, I can mode this 4 by this. So column is equal to mid by mode. Okay, so we'll calculate our current value. So how can we calculate the current value? So we'll go to this particular mid divide by m. So this is 5 divided by 3, and this, sorry, 4. M is 4. So what you will do, 5 divided by 4 give you 1, and this is 5 mod 4. This is also give you 1. Okay, so you got the matrix as matrix of row column. Okay, so this is 1 comma 1 and this 1 comma 1 having a value of 11. Okay, so what you will check whether this value is greater than target. So as you can see, target is 3, so we need to go in this direction. So we'll reduce our high to come at here. Okay, so we'll do high equal to mid minus 1. Like it's the same, we implement the binary search. Okay, so now our high will come at here. Okay, now we again calculate the middle. So middle is, you can say, 0 plus your high is 4. So 0 plus 4 divided by 2, which is 2. So you will come at, how can you come at? So you will do mid divide by m. So 2 divided by 5 is 0, and 2 mod 5 will give you 2. So you will come at this position, your mid is come here. So you compare with target, again you check whether this goes in this direction or left or right. So as you can see, again target is, value is greater than target, so we need to go in this direction. So we'll come at high at here. Similarly, we implement a binary search over it, and finally we find out the target. Okay, so I think it will be clear to you. Let's write the code for this. Okay, so what we need n matrix dot length, and we need m represent column and n is rows. We'll take our low from 0 and we'll take our high from n into m minus 1. So we'll simply implement a binary search while L is less than H. First step is to calculate mid is low plus high minus L divided by 2. We'll calculate the value first. So value, how we'll calculate? So matrix of, we'll calculate the row. So row will be calculated by this way, and your column will be calculated by this way. We'll compare value with target. If it is equal to, return true. Else if value is greater than target, that means we have to update our high. So height will be mid in left part, we have to go, else we have to go in right part. If we don't find any element, we return false. Okay, let's run it. Okay, so this is accepted. Let's submit it. So our code is submitted. Oh, and the time complexity is, you can say it's a binary search we implement, so it's the order of logn. Hope you like it. Thank you for watching my video.